All right, I'm going to go through some of the word problems here. This is the worksheet that starts with the city in the northern hemisphere. So this is number one. It says that the latest time of the sunset happens on day 172, and that's at 8 p.m., which is 20 hours. So if we were to just kind of sketch a graph here, we have at 172, we are at our maximum, which is 20 hours. And then at 3:55, we are back down to our minimum, which is 16. And so our sinusoid is going to look like that. Okay, so is that enough for us to get all the information? Well, let's find out. We know that if the maximum is 20 and the minimum is 16, that there is some midline that goes through the middle of those. Hopefully you can recognize that that's going to be at 18. So the midline is y equals 18. And then the amplitude, because we go 2 up or 2 down, looks like that. If I draw starting here at the maximum and go down, that looks like a positive cosine. Positive cosine. And that means that our phase shift is going to be right 172. And what else do we need here? We need the period. The period is going to be whatever this distance is times 2. So 355 minus 172, I think that's 183. And so if I double that, I get 366. So the period here is 366. So I can find B, which is going to be 2 pi over B equals 366. So I do that, divide by both sides by 366, I get B equals pi over, well, I doubled that to get here, so if I go back, it's 183. And then I have C over B equals 172. So I have that, which means if I multiply both sides by pi over 183, that'll get rid of the thing on the bottom here, and I'll get 172 pi over 183. And does that reduce? I don't think so. This would be 3 and 61. 61. Okay, yeah, we're good. So now we can just write our function. We have a positive cosine, amplitude of 2, so it's y equals 2 cosine pi over 183 x. And move to the right, so this is minus 172 pi over 183 plus the midline, which was 18. All right. Next problem. Oops. A Ferris wheel one. All right. Let's change colors just for fun. Okay, so a Ferris wheel has a diameter of 14.5 meters, rotates every 20 seconds. The bottom of the wheels, 1.5 meters off the ground. Okay, so this means that when you start, you are down here at 1.5. And then it takes you 20 seconds to get back down to here. So it looks like that. That looks an awful lot like a negative cosine graph. We have our midline somewhere in the middle here. And so because the Ferris wheel, try to draw a quick Ferris wheel here, it has a diameter of 14.5, that means that the radius is 7.25, which means that if I were to draw my diameter straight up and down, I would be 1.5 and then up 7.25 from there. That means that my midline is going to be at y equals 8.75. And hopefully you can see that from that the distance from the midline is also the radius, so the amplitude here is 7.25. And the period is 20. There's no phase shift because we started at the minimum. So, what did I say the amplitude was? Cosine. Oh, I didn't solve for b. 2 pi over b equals 20. b equals pi over 10. X, no phase shift, plus 8.75. Now, if you wanted to, you could not start at the bottom, and you could have a phase shift. You could move over. We could start here. Let's do it in red. Here. And now if I start with that, that looks like a positive sine graph with a phase shift of right. Well, if the whole period is 20, that means it takes 5 seconds to get to each of these parts. So that's right 5. And so I could write y equals 7.25 sine pi over 10x, and then I'd have to account for my phase shift, and that's going to be, well, that'd be pi over 10, so it'd be actually half of pi, and it's negative because it moved to the right. Or, if you wanted to, we could go crazy with a dark blue. We could say we started up here at this point, in which case that would be a positive cosine. No, that was supposed to be a negative cosine, and I didn't put a negative there. Why didn't anybody say anything? I hate not being in class. Just draw my marker. That should be a negative. Okay. All right, so this would be a positive cosine. And it would have a phase shift of right 10. And so we would get y equals 7.25 cosine pi over 10x minus pi, if you solve for c, plus 8.75. And we could do this yet again with this lovely point here. We could do a negative sign with the phase shift of right 15, and so on. I'm not going to write that one out. But you can see that there are multiple answers for this based on where you start that thing. Usually, if you can start with a 0 phase shift, though, that'll be the easiest. All right, let's move on to question number 3. This is a tied problem. Okay, so let's kind of sketch this out or write it out first. T equals 4. The depth is 18. T equals 10. The depth is 6 hours since midnight, so that's why we're doing 4 a.m. is 4 hours after midnight. Quick sketch. 1, 2, 3, 4. 18. 5, 6, 7, 8, 9, 10. Down to 6. So it's going to look like that. Draw a midline. So I need the number in the middle of those. So this whole distance is 12, so it's 6 up, 6 down. I said that backwards than the way I wrote it. So the amplitude here is 6. The midline is going to be y equals 12. If I looked at the period here, so this distance is 6 hours. And so it's going to go back up. It's going to be another 6 hours. So the period here is 12. And because we started at 4, the phase shift is right 4. And this looks like a positive cosine graph. It might be useful on the test if you write down which kind of function it is so that you know when you go to write it that it should be a positive cosine. All right, 2 pi over b equals 12. B equals pi over 6. C over b equals 4, which means that c is going to equal 2 pi over 3. And so we get y equals our positive cosine with an amplitude of 6. C pi over 6x minus 2 pi over 3. It's minus because it's moved to the right. Plus 12. All right. And let's move on to the last one. All right. All right, so this is a spring problem because it's spring. I know. Okay, so it's pulled down 60 centimeters and released at time 0. So at time 0, so normally it's here. At time 0, it's been moved down 60 centimeters from 80. So this is now at, y is at 20. And then release, it takes 2 seconds for the mass to return to the low position. So at time 2, it's back down to its low position. Okay. And hopefully you understand how springs work, that this distance down is the same as this distance up. Typically, if we had been in class, we would have done a nice little lab where we had springs and weights and we measured stuff and did this for real, but here we are. So, so that would be the same 60 centimeters up as well. Okay, so if we were to graph this, time 0, we're at 20. At time 2, we're back down to 20. But we know we have to go up to our maximum at some point in the middle. All right, so it looks like that. So this was 60, which means that if I was at 20, the midline here is y equals 80, which is where it is at rest. So we have a midline, y equals 80, amplitude is 60. We have our period is the distance it takes to repeat itself, so that is 2. And if we choose to make this, if you look at this graph, you should recognize that that shape is the shape of a positive, negative cosine graph. So that means that there's no phase shift. Again, you could pick positive cosine and go from this point, or you could pick a sine graph and figure out what the phase shift is for those, but the easiest is to go with a negative cosine. Whatever you can do with time 0, if it's one of the, if it's an easy one, you can just assume that there's no phase shift, and then you don't have to worry about finding a c. If the period is 2 pi over b, we know that that's equal to 2. So I get 2 pi equals 2b, or not 2b. That is not the question. All right, so I get b equals pi, y equals 60, it's negative cosine, pi, x, no phase shift, plus the midline of 80. And so if I wanted to, I could ask you things like, oh, where is this spring, this weight on the spring, when t equals 3? And what you would have to do is you would have to plug 3 into here. And you would get negative cosine of 3 pi plus 80. Cosine of 3 pi, on the screen, 1 pi, 2 pi, 3 pi. That's negative 1, so I'd have negative 60 times negative 1 plus 80. That's going to be 140. So it's at 140 centimeters, and that's going to be, if we go back up to this graph, that's going to be right up there at 3 seconds. Or I could say, where am I at, 3 or 1.5 seconds? So you would have to put in 3 halves and solve for that. And you might have to know what cosine of 3 pi over 2 is. So these are some of the things that I could ask as well. All right. Hopefully these videos are helpful. And if you haven't watched the other one yet, I have done both worksheets that we had with all these word problems.